Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called CCCC Cheese Time, right? By AQJHS, or Cheese Time. I don't know how you want to say it. Let's get to the rules. We have to divide the grid into 9 orthogonally connected regions and place the digits 1 through 9 once each in every row, column, and a region, however we come up with that. So, this is normal chaos construction rule set. What is an orthogonally connected region? It means in the region, you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid region because you can go from this cell to any other cell in the region just by going through edges, all while staying within the region. This is an example of an invalid region because these cells here, while they can get to each other by going through edges while staying within the region, they can't get to any other cells in the region just by going through edges while staying within the region. They'd have to go through a corner here or exit the region by going through edges here, neither of which is allowed. So those are examples of how orthogonally connected regions work. We have counting circle cave clue cheeses, which is why this is the CCCC cheese time, because we have the counting circle cave clue cheeses. Where a digit on a cheese, which are these circles here, which are on a cheese round, a round cheese? You mean a rounded cheese? I don't know. I'm not sure what that's supposed to mean. Counts the number of cells seen in its row and column, including itself, where region borders block sight. Also, a digit on a cheese round indicates how many times that digit appears on cheese rounds. Okay. So these cheese circles serve multiple purposes. In this region, say this was a valid region, then this cheese circle sees 4 cells because line of sight is blocked by region borders. And this is a region border, and this is a region border. So it sees 1, 2, 3, 4 because it counts itself. So in this case, this would be a 4. That 4 would also translate to that there are 4 4s in these round cheese blocks, right? So we could have something like a 4 here, a 4 here, and a 4 here. And if none of the other cheese circles are 4, then this is valid because we have 4 4s in cheese circles. So that's how these rounded cheese circles work. We also have skyscraper sweeper slices, okay, where the symbols, the cheese wedge, the pizza slice, and the fondue cheeses represent 3 digits from 1 through 9. So these are the same digit. The pizza slices are the same digits, and the fondue cheeses are the same digit. Outside clues indicate the number of cells seen in the direction of the clue from the grid edge until the first internal region border. So, for example, if this were a valid region here, then this cheese slice would have to be 4, because that's the number of cells seen in that direction until the first internal region border. And this would be 2, because that's the number of digits seen in that direction. Or sorry, this would not be 2. The cheese wedge would be 2. Also, outside clues are skyscraper clues, where its value is equal to the number of seen digits in the direction of the clue, where digits block any lower digits from being seen. So these also serve double purpose for these symbols outside of the grid. So as an example here, let's use this. Say we had 5, 2, and 9. This cell in this direction would only see 2 digits. Doesn't matter what these are because that's sort of extraneous. But because it would see the 5, it would not see the 2 because that's smaller than the 5 in front of it, and it would see the 9. And it could not see any other digit behind it because those digits are less than 9, guaranteed. So it would only see 2 cells in this direction. So that's why that would match the 2 outside of the grid. So outside clues are both skyscraper clues and the number of clues of cells seen until the first internal region border. Cells joined by an X have digits that sum to 10 and belong in the same region. So this is actually not a valid region because these two must be in the same region. So we could do something like now this, I guess. And this would be 5 for 5 cells seen until the first internal region border. And say we had a 3 here. If this is 3, this would have to be 7 because these two digits must add up to 10 because there is a tomato X between them. Also, cells joined by a black olive dot have a digits in a 1:2 ratio and belong to different regions. So this must be part of one region here, but this would be part of a different region here because they are joined by a black dot. And if we had a 2 here, say, then this would have to be 1 or 4 to maintain the 1:2 ratio between the dots. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's draw a boundary around the entire grid. Let's draw boundaries between all the black olive crop key dots. These have to be, so the pizza slice has to be at least 2 because these are in the same region. How many pizza circles do we have? We have at least 5 unique digits in the pizza circles. We could have a 9, potentially. So this is part of the same region because these two are part of the same region. Pizza slices are all part of the same region. So we could have 2 that way, we could have 2 that way. But it cannot be more than 4. So the pizza slices are 2 through 4. It cannot be 4. If this is 4, then this pizza slice would also have to be 4, but we know that these are part of the same region. So the pizza slices are 2 or 3. Could just be 2 there. Interesting. Okay. So these are part of the same region, but are not part of the red here. How many circles do we have? 5, 10, 13, 16, 20, 22, 25, 27. So that means the digits in the pizza circles must add up to 27. because they appear that many times in the pizza circle. It cannot be 7 unique digits. Hmm. So that means, ooh, if we have 2 here, I guess that could work. We could have 7 on one side and 8 on the other side, and then 9 somewhere in the middle. That is possible. Um, 1 to 2 ratio has to have 1, 2, 3, 4, 6, or 8 next to it. 5, 7, and 9 can never be next to a black crop key dot, because if you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, or 18, none of which are digits, though. So we have 27 circles. Let's count this way. 2, 5, 8, 9, 12, 16, 19, 4, 5, 24, and then 27 again. Okay. That means, okay, so that means the remaining digits must add up to 45 minus 27, which is 18. There's at least 3 digits that are not in circles. Cheese slices cannot be 1. Oh. If cheese slices were 1, these would all see only 1 cell in that direction. And this would then have to be 9, this would be 9, and that would be 9, and we have a repeat in the row. So these have to all be 2. So cheese slices are all 2. Because you can't go see more than this, because this has to be different regions. So this is part of green. This must be a different region because of the black olive. So we have 2 here, 2 here. The pizza has to be a different digit because they represent different digits from 1 through 9. So the pizzas have to be 3. So these are all 3. So this is part of the same region. These are part of the same region because they're part of the tomato, and the tomatoes have to join 2 digits that belong in the same region. So therefore, these now can only be part of blue. So we have a region border here. These 2 are part of the same region, whether they're red, green, or something else. Oh, this is 3. So this must be red that way. These have to be part of the same region. So we have region border here. We have 2 digits here that are part of the same region. So we have region border there. Fondue could be 1. It could also be like 9. So this sees 2 cells here. This sees 2 cells here. This sees 2 cells here. This is 3 cells here, so that's orange. Okay. So then we have boundary here. This is 2 here. So we know there's a boundary here. There's a boundary there. Interesting. Okay. So if this is part of blue, the problem with that is you cannot be part of blue here because this is only 2 cells before the first internal boundary. And the problem with that then is it has to go here then, but then this has to be part of the same region. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells in the region. So this cannot be blue. It must be another region. So this is yellow. Yellow has to go out that way because there's no other place to go out. This is not part of the same region as this because of this boundary here. So we know this only sees one cell before the first internal boundaries. So the fondue is 1. And this then sees only 1 cells in the skyscraper. So this must be 9. And this must be 9. So 9 cannot be part of the pizza circles. Because if it were to be part of the pizza circles, all 9 of them would have to be in the pizza circles. But this one can't be, and this one can't be. This is also 1, so that's the first internal boundary. Yellow has to go this way. Blue has to go this way, because blue has to expand out this way. So we have boundary there. We have boundary there. This sees 2 cells, and that's yellow. So no boundary. This is this boundary there. Yellow, we go has 7 cells in it, so we don't know what this can't be blue. Because if this is blue, we have blue, blue. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells. So blue can't go here because that would cut this off from a different region. So blue has to go that way, and that's done as a region because that's 9 cells, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll make this pink, I guess. So pink has to go this way. This is 2 here. You could go yellow, yellow there. That is possible. Go yellow, yellow that way. So yellow could go 1, 2 here, 1, 2 here, 1, 2 here. So these are all the possibilities for yellow. Red could be any of these also. It cannot go there. So red at most is only going to be 8 cells unless it goes this way. So it has to go that way, which means that's different from green. Red could stop there. No, red cannot stop there. If it tries to go all these, yellow is not going to form a full region. So red has to exit out this way. So we have 1, 2, 3, 4, 5, 6. These could be a different region. So it could be pink or something else. Okay. This is 3 as a region. This sees 3 in the skyscraper. This sees 2. So this cell must be smaller than this cell. Because it guarantees sees this cell, and it guarantees sees 9 somewhere in the column. So this one has to be smaller than that. So this cannot be 8. So this is greater than that, so it has to be 2 through... Well, 9 cannot be in a circle, in a cheese circle. So this is smaller than this one, too. So both of these are smaller than this. So it can't be 2, it's 3 through 8, then at most. This must be smaller than 8. So we have 1 through 7 there. It has to be smaller than at least one other digit. Same with these. It sees this cell. This has to be smaller than that one. This could be a 9, though, there. So that's possible. 1, 2, 3, 4, 5, 6, 7, 8, 9 is possible. Because you could have yellow go out that way. Sees 2 digits. Again, this digit has to be smaller than that. We know 9 has to be... Where is 9 in this row? It has to be one of these 2 in row 5. So this digit has to be greater than that, and this digit is greater than both of these because it must see just this one and the 9 in the row. Same with this. So this could be the 9 here, though. We don't know. But cannot have 9 be the first digit here, cannot be next to a black olive dot, cannot be on the pizzas, or not pizzas. I guess that maybe that cheese circles. So it has to be either here or here. If we had 8 here, that doesn't work because that's not, none of those are smaller than this digit. So this must be at least 3 up to 8. Cannot be 5 because these add up to 10. So we have 2, 3, 4, 6, or 7 adding up with 3, 4, 6, 7, 8 to add up to 10. Okay. So we already have 9 not in the circles. The other remaining circles must add up to 9 total. 8 because 45, again, minus 27 is 18. So the numbers not in the circles must be adding up to 18. We have 9 already. It could be 2 digits, either 1, 8, 3, 2, 7, 3, 6, 4, 5, or 3 digits, 1, 2, 1, 2, 6, 1, 3, 5, or 2, 3, 4 are possibilities. Okay. This digit must be greater than at least one other digit. So this is 2 through 8. This is 1 through 7 there. Same with this. 2 through 8. 1 through 7 there. Hmm. These can't be 9 because it must see 3. Oh, where is 9 in column 8? These can't be. None of the 9s can be on pizza or on cheese circles. Cannot be next to the black olive dots. Can't be here because this must see 3 cells, and if 9 is either of these, it sees less than 3 cells. 3 skyscrapers this way. So 9 has to be here. That means this is smaller than this because it must see 3 cells going this way. We also know this is a boundary. I guess we can make this medium. I have a feeling we're going to have something coming out that way, but that's just a hunch. This is smaller than this, so it's 1 through 7, 2 through 8 this way. Huh. We only see 3 cells this way. So that means we cannot have an 8 here. So this could be 1 through 7. And none of these could be 9. But these could be 1 through 8 as possible. No 5 there. 1 through 8. No 5 there. So 2, 3, 4, 6, 7, 8, 9 to add up to 10 with this digit. 2, 3, 4, 6, 7, 8, 9 there. Okay. So this is done. This is kind of done. This is not really done. We don't know about this. This one we don't have anything about. This sees 3 cells. Ooh. So it sees the 9 here. So this again is 1 through 7, and this is 2 through... It doesn't have to be 2 through 8. 1 through 8 here, we could see... We don't have any other information there. This sees 2 cells this way. So it could be 8 and 9 possibly that way. That is possible. Um, circles. 1 to 2 ratio. Um, hmm. What else do we know? Um, green has to go out here somewhere. Um, yeah, I guess this one's done also. Um, um, hmm. What else do we have? Technically, this could be 3 with 1 and 2 there, and then you have 9 there. That is possible. Hmm. Um, hmm. Red could go to here. We have 1, 2, 3, 4, 5, 6. Red can only go 2 more. I get, well, no, pink could go here. So red could go 3 more. Pink could go here. So 3 more could go that way. Cannot cut off pink because this is a separate region. Can't be red going this way. Because then this would be too large of a too many cells in this region trying to be part of the red or the yellow region. So assuming red were part of this, that just doesn't work. So pink has to get out. Hmm. Huh. Where to next? Do we do the number of circles? Can we do number of circles? Really is the question. Um. Hmm. Uh, hmm. Um. Hmm. I'm not sure where to go next with this. Pink obviously cannot go down here. That would cut off yellow. But red could go here if yellow goes this way or yellow goes this way. Or you could have two yellows here, two pinks here, and then red goes this way. Hmm. Oh, digits in cheese circles indicate how many times that digit, how number of cells seen in its row and column, including itself. Okay, that's where I'm missing that. This sees, so we know this sees 1, 2, 3, 4, 5. So this is 5. Okay, there we go. This sees 1, 2, 3, 4, 5, 6. So this is 6, which makes this 4. So that helps a lot. No 6 there, no 3, 6 as a pair. Oh, in circles, you can never have a 1. Because it'll always see some other cell in the row or column. So you cannot have 1 in pizza or whatever it's called. No 6 here. No 6 here. No 4. No 5. Because 1 is always going to be orthogonally connected to its region, and so therefore it will see at least 2 cells. This sees at least 3 cells here. So the corresponding 8 and 2, 7 and 3, 4 and 6, oops, 4 and 6, or 3 and 7 there. Excuse me. This sees 1, 2, 3, 4, 5 at least. It cannot see that cell or that cell, so this can't be 8. So this is 5, 6, or 7, therefore this can't be 7 there. 5 eliminates 5 there. This digit must be greater than 5 because it sees this cell, but it cannot see that cell. This sees, at most, it sees 3 or it sees 4 cells because it sees either that one or it sees these 3 by themselves. So this is 3 or 4. That this has to be then be 6 or 7 correspondingly. This sees 5. This sees at least 3 cells. Well, not necessarily. Could technically see 2. No, it has to see at least 3. It has to see that one, and then it must orthogonally connect out. So this has to be at least 3. Cannot be 4, 5, or 6. It could be 7. It could be 8, technically. Huh. Okay. Remaining digits in the blue region, we have 1, 2, 3, 7, 8, 9. Okay. Pizza. See however many. So this sees at least 3. And this must see more. Interesting. So this sees at least 3. It sees at least 4. This can't be 4, though. If this is 4, that means this is 3. That would eliminate all possibilities for that cell there. So this has to see at least 5. So this has to go this way, then. Hmm. We're gonna have to have 8 eights if we have 8s in pizza circles. Oh, that's gonna be difficult. Hmm. Oh wait, we don't have pizza circles or cheese circles in row 8, which means that we would have known 9 couldn't be there. This, if this is red or yellow, it's guaranteed to not be an 8. Because yellow can only see at most 6 cells here. Red can only see at most 1, 2, 3, 3 cells here. So this cheese circle is not going to have an 8 in row 9. We're not going to have an 8 in row 8, which means we can never have an 8 in the pizza circles because we don't have enough cheese circles to have 8. So this must be less than that. No 8 here in pizza circle or cheese circle. So we have to have 2 through 7 guaranteed in all the cheese circles. Interesting. No 1 here. No 1 here. Okay. So these all have to be 2 through 7 here then. Which means, and this can't be 8, so this is 2 or 4. Because we can't have an 8 seeing all yellow cells or the 8 red cells here. Hmm. How many rows have 5 red circles in them? We have 6 cells that, 6 different digits that can be in the circles. So we have 1, 2, I think that's it. 2 rows with all 5, with 5 circles in it. We have 5 and 6 here. This could be 2 or it could be 4. Hmm. Um. Huh. Um. Hmm. So we don't have any circles in row 8. We do have 2 unique digits here. Can this be yellow? If we have yellow, yes, it could be. If this is yellow, yellow, we see 7 here, and this would see 6. If this is red, it would be 3, which is possible. Hmm. 9 eliminates 9 from being here. What else do we have? So if this sees 3, That means it would have to go 1, 2, 3, 4, 5. This would be part of a different region. So it's C3. That mean okay. How would that work? This would then be boundary here. This would then have to be yellow. So this would be yellow, which means this would have to be yellow here to connect. These could not be yellow or pink. So this would be boundary this way. Oops. Okay. We'd have boundary there, because red is full. That's 9 cells. This would see 3. This would be 5. So far, this is okay. We'd have boundary here. So I'd have to go up. So you'd have pink going that way. No 3 here. I mean, it's potentially there. No 3 here. No 3 in the red region. No 3 here. No 3 there. We have to have a 3 somewhere in the yellow region. And it would have to be one of these. So that would eliminate 3 from being in the blue region here. So 3 in the blue region would have to be there. That's interesting. Again, no 3 here, no 3 here. So this can't be 3 and 6. No 5 here. I mean, this one looks okay-ish. Oh, that is interesting. Yeah, this might actually be the solution. So let's not go down that path. The only other thing is if this is 7. So if this is 7, we are guaranteed to see 1, 2, 3, 4, 5, 6, and then maybe 7 there. So this would not be 7 here. But the problem is these would all see at least 5. So then this would have to be 5, 6 as a pair. That eliminates 6 there. So this would see one of these would see 5, and the other one would see 1 more outside. So you'd have boundary there. This would see one of these would see 5. This would see 7, so this would have to be not yellow. That would be pink. So, and then I guess you could still go that way. This would see 7 that way. 5, 6 as a pair. No 7 there. You could have 2 yellows, 2 pinks, 2 reds, some mix. I don't know. No 5 or 6 in the pink regions. That's not that helpful, though. We have 1, 2, 3, 4, 8 here. Okay. Oh, one of these would have to see 1. So this can never be pink. Right? Because one of them has to see 1 in this direction or this direction to see 6 cells. So we could have yellow, yellow. We could have red, red. We could have yellow, yellow there. Yeah, this is kind of convoluted. What else do we have? I was hoping this would lead to an immediate contradiction, but we don't. We could have yellow, yellow, red, red. So what happens if we had... Maybe make the assumption that this is yellow. So if this is yellow, we cannot have another yellow here, because that would be 1, 2, 3, 4, 5, 6, 7, 8. Then if the yellow were here, this would see 5 and 1, that's 6. This would see 5 and 1, that's 6. So this cannot be yellow in that case, which means yellow would have to be here. So yellow's there, this would be 6. Now it sees 6 cells in the region. This would see 7 cells in the region. That would force this to be 8. No 6, 7, or 8 there. No 6 in the yellow region. This has to be less than that. 8 eliminates 8 there. No 7, no 7 or 8. No 6, 7. We have 1 through 5 here. So no more yellows here. That would force, we know this can't be 3, this would be 7. So then we have that situation again. No 2, 3, 4, no 7. Sees 5 that way. We cannot go pink, pink, because we have to have a pink be one of these cells. So this is guaranteed to be red. So far, this is fine-ish. No 6 here because of the 5, 6 pair in the column. This is fine too. I was hoping again this would lead to a contradiction, but not right now. So 6 can't be either of these, which means these can't be 3 to be in a 1 to 2 ratio. Um... Maybe we should have gone through the 3 more. Ugh, this is annoying. There's quite a bit of possibilities here. It's basically trying to find the contradictions here. That's kind of the issue. Hmm. So I think this has to be 3 or 6, though, right? I guess it could be 4, technically? No, because that would block yellow. So this can never be pink here. Can this be yellow, yellow? Yeah, if that's 7. But this can't be pink. If this were pink, then this would have to be pink. This would see 7 cells. You'd have 1, 2, 3, 4, 5, 6, 7. So then this would be 5, 6 as a pair, but then the 5, 6 would have to see one of these digits here, and that's therefore this can't be pink. So no pink there. So maybe make this 3 again and see if that leads to contradictions. Oh boy, okay. No pink here. This sees 3 cells. Pink has to go out this way. So no 3s there. This can't be pink. This has to be yellow. Yellow then has to go that way. That's yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are not yellow. That's all red. I was hoping we... Anyways. Let's continue. Pink, pink. This is a separate region. Could be orange. Could be some other one. Don't know. This sees 3. This sees 5. No 3 there. No 3 here. 3 has to be in one of the yellows. So one of these 4 is yellow. 3. So this can't be 3 here or here. Which leaves a 3 here. So no 3 here. No, one of these is 3. No 3. Okay, so one thing is that forces this to be 4 and 6. So that's 4 and 6. This is part of the same region. 4 eliminates 4 here. So that's 2. That must be 2 and 1 here. Interesting. So no 4 or 6 here. No 4 or 6 here. So 2 and 7 would have to be with 3 or 8 here. 1 eliminates 1, 2 as a possibility here. So this cannot be 3 here because that would see these digits before we would see the 9, or one of these digits before it would see the 9. So this has to be 8 and 2 there. Therefore, this cannot be 2. This must see 5 cells, at least. So this, and it cannot be 7 cells. So this would be 5. So this would have to see more than 5 cells. So it has to see those cells there. This would see specifically 5 because it can't be 6. So then this is border there. This would see 6 or 7. We have boundary there. No 1 or 2 here. It's 7. No 1, 2, or 7 here. It's 8. 7 eliminates 7 there, so it's 5. That leaves that as 3. So then we would have boundary there. Okay. This is kind of really, actually kind of, this is really convoluted. No 2 here. This feels very, ugh. A lot of work just to disprove these things. Ugh. Okay, this can't be 6. That would see too many digits. No 7 here. No 7 here because of 7 in the row. No 8 here because of 8 in the row. So it sees 7, 8, and 9. That's fine. It sees 3, 5, and 9 here. These are separate regions, so this must go out as a separate region here. That means it must go out there, but then this is stuck. So that's the contradiction we reach, if this is 3. So it can't be 3. Okay. I don't like that. That's really convoluted way just to get to show that that's not... That can't be 3. I don't know. Anyways, now we know... This is 7. So it sees at least 5 cells this way. But these can't be 7. And it can't be 2, 3, or 4 because they see at least 5 cells. So it's 5, 6 here. Again, this sees 7. Then therefore this must be 5 cells that it sees in total. So this is 7. This must go pink here. And we could go pink down there. Or we could go yellow, yellow. We don't know. So this is 5 and 6. We have at least one of these is pink. Or exactly one of these is pink, I should say. We don't know what that is. So we could have yellow, yellow here, or in pink, red, red here. If this is yellow, though, so if this is red, this has to be red, red. That's yellow, yellow. If this is yellow, though, we could have yellow, yellow here, and this could be pink or red, and this is guaranteed to be red. So either this is red seeing 3 cells, or this will see 6 yellow cells here. So if this is red, this sees 5 cells. If this is yellow, this would have to see 7. Interesting. So we have 5, 6, 7 there. Aha. I see it. So if we try to have this be 5 and this be 3 as red, the problem is we don't have a 7 in row 9 in a cheese circle. We don't have a 7 in row 8 in a cheese circle. And we don't have a 7 in row 6 as a cheese circle. So there would not be enough 7s to be in all the circles. So this cannot be 5 and 3 there. This must be 7, which makes that a 6. So this must be red, not red here. It's yellow and yellow. Therefore, these can't be yellow. Therefore, that's red. So we know this is boundary. That means this can't be 6 or 7. It's 8. That eliminates 6, 7, and 8 in the rest of the yellows. So I was right. No 7 here, no 7 or 8, because I was getting the feeling that this was actually the solution path. So I was like, oh, it can't be this one then. Let's try to find another way. 6 means this can't be, no 6 here means because of the 5, 6 pair in the region, means this can't be 6, this can't be 3 here. So no 6 here means this can't be 3. No 6 here means this can't be 3. We have to have 1 through 5 here. This digit must be smaller than that, so it has to be 1 through 4. Remaining digits of the pink regions are 1, 2, 3, 4, and 8. And 9. So this could be 9. 1, 2, 3, 4, 8, 9. No 4 here because of 4 in the row. Remaining digits of column 5 are 1, 2, 3, 4, and 8. 7 here means this can't be 7 there. This cannot be 8, because if this were 8, then it would see 3 cells going this way. This can't be 8 because of 8 in the column. Where is 8 in the blue region? It has to be one of these 2 cells. That eliminates 8 in the rest of the row. So no 8 here, no 8 here. Huh. 5 or 6, 5 or 6. We have 6 here, 7, 7. These are not... We already have in row 6 and row 8, no 7 in a cheese circle. So we need a 7 in every other row to have a cheese circle. So one of these is 7. One of these is 7. One of these 3 is 7. This could be 7, or one of these 4 is 7. None of these can be 7 because of 7 in the column. And then one of these 3 is a 7 there. Okay. Okay. So we have the pink can only go one more in each direction, in any direction from here. Maybe this should be dark. This sees... Oops. My mouse just lost power. Let me just get that. I'll be right back. And I'm back with my mouse having batteries. Whoops. Okay. Let's continue. Yeah, these could all be pink, but this could be red also. This could be multiple things. Let's remove these for now. So 7 either has to be here or it has to be here. Oh, that's interesting. If 7 is here, it'd have to see 5 here and then these two. That is potentially possible. If 7 is here, it would have to see 5. Could be, if it's not a part of orange, I don't think that works. If it's not part of orange, it would see 5 here and 2 here, but that would block the orange from orthogonally connecting to another region. So it would have to be part of orange. It would see 1, 2, 3, 4, 5, 6, 7. And then this would be... Oh, that... Yes, that would be 4 and 6, and that would work. So if this is 7, it would have to go that way. Or it could go that... No, cannot go this way, because that would block orange from being a 9-cell region. So would this work? If we have 7 going this way, we have how many cells left? This has to go this way. 1, 2, 3. This would see 3. 1, 2, 3, 4, 5, 6, 7, 8, at least 9. So this would be orange. So again, this would have to be 7. That's what I'm trying to make. This sees only 3 cells, so this would be 3. This would be 3 and 7. No 7 here, no 7 here. No 7 here. No 7 here. Three would make this not 3. This sees more than 2. It cannot be 3 because it's in the same region, so it'd have to see at least 4. So this is orange. 2, 3, 1, 2, 3, 4, 5, 6, 7. This could see 2 or 4. Cannot see 4. Because it would only see these 3 cells. So this would be 2. Therefore, it would be blocked there. This would be blocked here. Orange would have to continue on to here. But then this is problematic because all of these see the same amount of cells. So 7 cannot be here. So we know the 7 in this row, row 5, has to be in this circle because this can't be 7 there. And again, this can't be 7 going this way or this way, because this would block the orange cells. So it has to be part of orange, and this is 7, which makes this 6. That's 4. This sees 1, 2, 3, 4, 5, 6, 7 that way. Because this must see 1 here. Actually, it doesn't have to go that way. And in fact, it probably can't. So this sees 4 that way, so it's 4 and 6. That means this can't be 6, it's 5. That leaves that as 6 there. So this sees only those 5. So we have boundary here. So this is boundary there. No 4 or 6 here. That means this can't be 4 or 6 here. No 7 here, which means no 3 here. 6 eliminates 6 here. So this cannot be 3 and 6. We are guaranteed a 2 there. One of those two cells to be in a 1 to 2 ratio. No 2 there. So we cannot go pink that way, because this can no longer be 2, because this is either 1, 2, or 2, 4 there to be in a 1 to 2 ratio. Why can't it be 4, 8? It can't be 4, 8, because then this cell would be 3. It would see only 2 cells there. So this cannot go pink there, because this would see 6 cells. This would not be able to see 2. So pink has to go this way, which means this must be part of red. So this is done as a boundary there, boundary there. We see at most 1, 2, 3, 4. Sees 4, 5, 6, 7. So these are both orange. No 7s here, no 6s here. So if we go all the way to orange there, that's not going to work, because these would only see 6 cells. So this cannot be orange. This must be dark to be part of that. What? This cannot be 3 then. So this has to be at least 4. No 7s here. This is not part of that region. We could see 4 here, 5, 6, 7 is possible. But if that's the case, this would only see 4 orange cells, because the orange region would be done as a whole. So it cannot, so we have to have orange here. And that's 8. We have to see 1 more cell for here. It cannot be there, because then this would be 4 cells seen. And we already have a 4 in the region, so this has to be there. That sees 5 cells. This is a different region. This is done. So this is 5 cells seen in this direction. So no 4 eliminates 4 here, so that's 2. This is kind of problematic, I feel. Huh. This is 1 then to be in a 1 to 2 ratio. 4 eliminates 4 here, so that's 5. So this sees 5 cells, this sees 7. 1, 2, 3, 4, 5. This sees 7. 1, 2, 3, 4, 5, 6, 7. This sees 2. How is that going to work? No 1 or 2 here, it sees 3. This has to be 8 for the only remaining digit. No 5 here. This sees 3 cells, so this is 3. 7 eliminates 7 here. No 8. This sees 6 cells. So that's 6. This sees 1, 2, 3, 4 cells. How is this only seeing... Oh. No, can't see... How is this only seeing 2? This has to see 3. And then this is blocked. So this is not seeing... What the... Shoot. Where did I mess up here? Ugh. Don't like this. Don't like this at all. Too many random things happening. 8 and 2. No 2 here. Then this must be 2. One, two, three, four, five, six, 7, 8. So this could be red still. Ugh. 1 eliminates 1 here, so it's 4. We have 5 and 9 as a pair. This can't be 5 because of 5 in the row in the region, so that's 9, that's 5. And that's a contradiction. So we've got way too many contradictions here. I'm gonna have to stop here because I have another appointment I need to get to. This is annoying. Okay. Well, I'm gonna have to figure this out later sometime. Anyways. I'll see you in the next video then. Hopefully we can get through this. I think we just have to restart this and then figure out where our logic went wrong. Anyways, I'll see you next time on Frank Puzzles. Take care.